Rainbows. They are nature's own masterpiece, a breathtaking spectacle that never fails to captivate the young and old alike. From the moment we first lay eyes on one, we are drawn into its magical allure. Imagine this: you're outdoors after a refreshing rain shower. The sun peeks through the retreating clouds, casting its golden rays across the sky. The air is crisp, and the world feels renewed. And there it is, a magnificent arc of colors painted across the canvas of the heavens, each hue blending seamlessly into the next, creating a perfect spectrum. From ancient myths and legends to modern-day art and literature, rainbows have held a special place in human imagination for centuries. They have been depicted in countless stories, symbolizing everything from divine messages to bridges between worlds. They are symbols of hope, promise, and the sheer beauty of the natural world. A reminder that even after the darkest storms, there is light and color waiting to emerge. But have you ever stopped to wonder what makes these ethereal displays possible? What scientific phenomena come together to create such a stunning visual treat? What magic lies behind their vibrant colors? The answer lies in the interplay of light and water, a dance of refraction, reflection, and dispersion that transforms ordinary sunlight into a spectrum of wonder. The answer, as with many wonders of the natural world, lies in the fascinating realm of science. Rainbows are not mystical illusions, but rather optical phenomena, formed by the interplay of sunlight, water droplets, and a bit of physics. The key ingredients are simple sunlight and raindrops. When sunlight, which appears white to our eyes but is actually a combination of all colors, enters a raindrop, something truly fascinating happens. It sets off a chain reaction of refraction, reflection, and dispersion, ultimately resulting in the colorful arc we call a beautiful rainbow. Let's break down these fascinating scientific terms: refraction, reflection, and dispersion. These phenomena are fundamental to understanding how light interacts with different materials and surfaces. Refraction is the bending of light as it passes from one medium to another, like from air to water. This bending occurs because light travels at different speeds in different media. Think of a straw in a glass of water. It appears bent at the waterline due to refraction. This is a common example that visually demonstrates how light changes direction when it enters a new medium. Reflection, on the other hand, is the bouncing back of light when it hits a surface. This phenomenon is what allows us to see objects that do not emit their own light. A mirror, for example, reflects light, allowing us to see our image. The smooth surface of the mirror causes light to bounce back in a predictable manner, creating a clear reflection. And finally, dispersion is the separation of white light into its different colors, much like a prism does. This occurs because different colors of light have different wavelengths. This is because different colors of light have different wavelengths and bend at slightly different angles when passing through a medium. This bending at different angles causes the light to spread out into a spectrum of colors, creating a beautiful display like a rainbow in the sky after rain. A rainbow's colors, where do they come from? Have you ever wondered how these beautiful arcs of colors appear in the sky? So when sunlight enters a raindrop, it is first refracted, bending as it moves from air to denser water. This bending of light is the first step in the creation of a rainbow. The light is then reflected off the inside surface of the raindrop. This internal reflection is crucial as it directs the light back out of the raindrop. As the light exits the raindrop, it undergoes a second refraction, further separating the colors. This second bending of light is what spreads the colors apart, creating the spectrum we see. This separation and reflection of light create the rainbow we see. Sometimes, under the right conditions, you might even see a double rainbow, where a second, fainter arc appears outside the primary one. Remember that white light is comprised of a spectrum of colors: red, orange, yellow, green, blue, indigo, and violet. These colors are always present in sunlight, but we only see them when they are separated. Each color has a different wavelength, with red having the longest and violet the shortest. This variation in wavelength is what causes the colors to spread out and form a rainbow. This difference in wavelength is what causes the colors to separate or disperse when light is refracted. The same principle can be observed when light passes through a prism, creating a beautiful spectrum of colors. Rainbows have fascinated humans for centuries, leading to a plethora of myths and legends. In many cultures, rainbows are seen as bridges to the divine, symbols of hope, or even as pathways to hidden treasures. Let's explore some of the most intriguing myths surrounding these natural wonders. In Norse mythology, the rainbow, known as Bifröst, was seen as a bridge connecting Midgard, the realm of humans, with Asgard, the realm of the gods. It was guarded by Heimdall, who stood watch at its end, ensuring that only the worthy could cross. In Irish folklore, rainbows are famously associated with leprechauns and pots of gold. Legend has it that if you follow a rainbow to its end, you'll find a pot of gold hidden by a mischievous leprechaun. In Chinese culture, rainbows were once thought to be the result of a goddess repairing a crack in the sky with 5 stones of different colors. This myth highlights the belief in the rainbow as a symbol of unity and harmony. As we move on, let's delve into the science behind double rainbows and other fascinating rainbow phenomena. Beyond the primary, double rainbows, and more, the most common type of rainbow is the primary rainbow, characterized by red on the outer edge and violet on the inner. However, sometimes we're lucky enough to witness a double rainbow, a fainter, secondary rainbow arching above the primary one. Double rainbows occur when sunlight is reflected twice within the raindrops. The colors in a secondary rainbow are also reversed, with violet on the outer edge and red on the inner. This reversal happens because the light takes a slightly different path within the raindrop during the second reflection. Other fascinating types of rainbows include the sheet bow, which forms in mist or fog, creating a broad, diffuse arc. Extraterrestrial rainbows, though rare, can occur on other planets with atmospheres like Mars. Supernumerary rainbows feature additional, fainter arcs inside the primary rainbow caused by the interference of light waves. Each type of rainbow offers a unique glimpse into the magic of light and water interacting in our atmosphere. Moonbows and fogbows. Rainbows without rain? While rainbows are most commonly associated with rainfall, you might be surprised to know that they can appear with other forms of water droplets in the air. Moonbows, as the name suggests, are rainbows created by moonlight instead of sunlight. They are much fainter than their daytime counterparts and often appear white to our eyes due to the lower intensity of moonlight. Fogbows, on the other hand, are formed by the interaction of sunlight with mist or fog. Due to the much smaller size of water droplets in fog, fogbows appear white or very pale in color, the enduring allure of rainbows. From the science behind their formation to the sheer variety of forms they take, rainbows are truly a marvel of the natural world. But perhaps what makes them so captivating is not just their scientific explanation, but the sense of wonder and joy they evoke in us. Rainbows have a way of reminding us of the beauty and magic that exist all around us. If only we take a moment to look. They are a symbol of hope, a promise of brighter days ahead, and a reminder that even after the darkest of storms, there is always beauty to be found.